So I am here with some question on capacitance. Okay, now without any further waiting, let's start. Okay, now here is a combination of capacitance. Okay, now let's start. In this question, it actually says the find the equivalent capacitance between A and V. So let's find the equivalent capacitance between A and V. Here we can see it is like a circle, and there is a breakpoint A and B. Okay, so while I'm doing this, I actually say that you actually do these types of question by reducing the capacitance one by one way. Okay, now actually we goes to in a simpler form so that we can evaluate and know where it is connected in series or parallel. Okay, A and B. So there is no electrical element here, so it is a a B. Okay, now this capacitor 1 2 3 and 4. So one is connected with A and B, and 2 and 3 is connected A and B. Okay, 1 2 3, and here also see that 4 is connected over A and between the A and B. Okay, this is our A and this is our B. Okay, now all have value C. So these two is connected over in parallel. So A and B, where this is equivalent, C equivalent is equal to 1 by 2C plus 1 by C is equal to okay. Now we have an equivalent capacitance of 5C by 3. Okay, now the second question. Okay, if this is A and this also be A, because there is no current element. Okay, electrical element, so this is also our B. Okay, now this capacitance we name the capacitance 1 2 3 and 4. So here we can see a simple diagram and draw a simple diagram of capacitance between the parallel and series combination. Okay, now we can see that capacitance 4 has connected to our A and B. Okay, now this is our A and this is our B. Okay, this is connected over This is capacitance 4, and 1 2 3, 1 2 3. Okay, this is connected in series. These all have a value of capacitance C. Okay, now this is, so this is have a value of C by 3, and this is C. For C by 3. So the equivalent capacitance between A and B has a 4C by 3 value. Okay, now we can watch this, that the third question has a infinite capacitance. Okay, now before going to the infinite capacitance, we actually have to inform that infinite is a quantity. If we added and subtract some value, then infinite remains infinite. So if we actually subtract this circuit and this circuit with a symmetrical value, then the capacitance have a remains its equivalent capacitance. Okay, so this values goes to infinity. Okay, now it is our C and it is our 2C. It is C and it is 2C. C 2C, it is a value of capacitance. Okay, now we suppose we give all the equivalent capacitance of from this is from this. Okay, because there is a symmetry to C1. C1. Okay, now this the all the equivalent capacitance of this combination also be C1, because to add some capacitance circuit in an infinite capacitance does not fail. Okay, now this is in series. Okay, or C1 is equal to, because the equivalent capacitance is also C1. C1 is equal to C plus 2C cross C1 by 2C plus C1. Okay, now C plus 2C square plus C1 plus 2C1. Okay, and this multiply by C1. Okay. You cancel each term. Okay, now it is like this. Okay, c1 whole square plus minus c1 to 0. Okay, now it is a quadratic equation of c1, and this is the coefficient c and 2c square. Okay, now ax square plus bx plus c is equal to 0, so x is equal to minus b plus minus root of 5 b square minus 4ac by 2a, or c1 is equal to c plus minus c square minus 4 into 1 into minus 2c. We know that there is no negative value of capacitance, so we ignore the negative value. So equivalent capacitance is 1 is equal to c plus 3c by 2 is equal to 2c. Okay, so the question number 4, a capacitor with charge q and distance between the plate d. Now one moved to have a distance 2d. Now we applied force because it is positive work done. Okay, now 2d. Now what will be the external force? Find the work done by the external work. Okay, now we know that to evaluate the force, we actually, to evaluate the work done, we actually know about the force. F is equal to q square by 2a epsilon naught. Okay, is equal to constant, so work done is equal to w is equal to f dot x. 2a epsilon. It is a process number 1, and process number, this same math can be do with process 2. Okay, now where this the process 2 work done is equal to change in potential energy, u final minus u initial, so q square by 2 cf. Here is the cf means final capacitance minus q square by the 2 c initial. Okay, now cf is equal to 2d. Okay, now here is two square plates L cross L and dielectrics. Okay, arrange as shown. Okay. Now draw a 3D diagram of this capacitance. No, it is actually less. Okay. We actually draw a simple diagram to evaluate this. Actually, it is half between the area also and also the distance. This dielectric slab. Okay. This dielectric slab have a value of length L by 2, and this is T. Okay, and these have a same length with the area of the capacitance. Okay, like this. Okay. Okay, this is our C1, C2 and C3, where C2 is equal to C2 has a dielectric constant, and C2 is inserted with the dielectric slab K. Okay, now C1 is equal value have it is the dielectric constant of the slab, because CR epsilon naught R is equal to K epsilon naught. Okay, where the epsilon naught is the dielectric value of the air or a vacuum. Okay, epsilon naught A by 2, but here it is not equal to D by 2. Okay, it is equal to T. Here we actually use T, so it is T by 2 and it is T by 2, it is T. Okay, now the equivalent capacitance. Two in K plus K plus 1, 3K plus 1 and 2 into K plus 1. So this is the value of effective capacitance between A and B. Okay, now here is a question that says that find the equivalent capacitance between A and B, and we can here watch that this is not a simple capacitance that can be reduced by doing the process of reducing of series and parallel combination of capacitance. So here we should use some process that is called the nodal analysis. Okay, at first we have to something say about I have to something say about the nodal process. Okay, nodal analysis. Okay, now I actually draw a diagram. There are two laws to evaluate these types of combination of capacitors. Okay, now the first law have a two subsection. One is called the so attach a battery of VAB of voltage VAB. Okay, now this is our positive point and this is our negative point. So this is positive, positive, Q1, Q2, minus, 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 and it is Q3, Q4, plus, 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 minus. It actually not bother about whether we should give this minus and this plus. Okay, now actually because we gave the positive value here, so this also be plus and this is negative, so these 2 points is also negative because it is directly attached to the negative point of a battery. Okay, now q1 plus q2 is equal to q3 minus q4 plus q4, or q1 plus q2 minus q3 minus q4 is equal to 0. Okay, because it have a same charge, because it is connected to positive and it is connected to negative, and so that the summation will be 0. Okay, this is first subsection, and the second is we have to know about what is isolation. So this part is isolate from all the circuit, these two parts. Okay, so q3 plus, so this for this isolate system the charge remain constant as initial as it was. Okay, so initial condition there is no battery, so the charge will be 0. Okay, now q3 plus q5, it is our q5, this is positive, minus q1 is equal to 0. And for this section, for this isolate system, we can saw that this is plus q4 minus q2 minus q5 is equal to 0. So I get two law. Okay, one is that the battery, if is battery the connected, then q1 plus q2 is equal to q3 plus q4, and we find out the isolate system of this circuit. Okay, now see, for this isolate system q1 q3 plus q5 minus q1 is equal to 0, and q4, this is positive, q4 minus q5 minus q2 is equal to 0. Okay, now second law is all about the conservation of energy law. Okay, now is as we actually use a battery, Now we have to draw the same diagram by using a better. Okay, plus minus minus plus plus minus minus plus minus. Okay, q1, q2, q3, q4, q5. Okay, now potential drops. Now we can draw a cert. Okay, now we draw two path. It is path 1, and also draw a path with containing the whole things. Okay, now this path is like this. It is our path 2. Actually we use this path 2 to eval to take the value of voltage or whole voltage V. Okay, now if we take this path we cannot get the voltage. Okay, now I also saw that this is our positive and this is negative. So if we goes through this, then the potential will be dropped, and if has it has a value of q and c, so potential drop will be minus q by c. Okay, minus because the potential is drop. Okay, now actually if we are going through this path, we actually saw this is potential drop, this is potential drop, and this is potential gain. Okay, now all have a capacitance, have a value of c1, c2, c5, c3, c4. Okay, now c1 by, sorry, q is equal to cv, or c is equal to q by v. Okay, so this is potential gain, q2 by c2 minus q5 by c5 minus q1 by c1 is equal to 0. And second is, this is potential gain. Okay, so v minus q1 by c1 minus q2 q3 by c3 is equal to 0. Okay, so we can get four equation. If we want any other equation also get by using this path. Okay, and this is the equation called the energy conservation law, and we also get from the Kirchhoff circuit diagram law, Kirchhoff voltage law, and Kirchhoff circuit law. It is actually a Kirchhoff circuit law, and it is Kirchhoff voltage law. Okay, now I am doing the problem. Okay. So this is isolated. Okay, I first this is C to C to C C. If the value of the ratio is C by 2C and 2C by C, like C1 by C2 is equal to C2 by C3 by C4 of the previous capacitance, then we can use that Wheatstone bridge principle and we can remove this capacitance. But actually here we can watch that C by half and 2 have a ratio. Okay, so we cannot use actually Wheatstone bridge principle, so we actually dotted the isolate plates. Yeah. Okay, now this is our Q1 Q2 and bisymmetric Q2 Q1. Okay. Minus Q2 plus Q1 minus Q3 is equal to 0. As the battery is connected, so Q1 plus Q2 is equal to Q. Okay, total charge on the battery, Q, and also draw the potential. Okay, minus Q1 by C minus Q1 by C minus Q3 by 2C plus Q2 by 2C is equal to 0, or Q2 minus Q3 minus 2 Q1 is equal to 0. So solving this three equation 3, equation 2 and equation 1, we get Q1 is equal to 2 by 5 Q, Q2 is equal to 3 by 5 Q, and Q3 is equal to minus Q by 5. Okay. So VAB is equal to Q by C equivalent. Now Q1 by C plus Q2 by 2C minus V is equal to 0.